Good morning to one and all. Today I'm going to explain about concrete technology subject. Okay. Once the students complete this course, you will know what are all the various ingredients used for making concrete and its role. Second one, you can determine the fresh order and engineering properties of concrete. Third outcome will be understanding non-destructive testing. And fourth one is about the durability problems in concrete. And fifth one, how to do the mix design. So I will tell the unit wise content which you are going to study. So first unit deals with the cement. What is meant by cement? How to manufacture cement? What are all the properties to be tested to assess the quality of the cement? And about admixtures. And in second unit, you will be studying about aggregate. What are the classification of aggregate regarding water quality, and third one, how to manufacture a concrete. And in third unit, you will see about fresh and hardened property. Once the concrete is made, what are all the fresh property tests to be done, and what is meant by segregation and bleeding. And in the remaining half, you will study about the hardened property, where the water cement ratio, Abraham's law you will study, and also various tests conducted on the hardened concrete. In fourth unit, you will study about non-destructive testing. That is, without damaging the concrete, you will be knowing its relative strength and other quality properties. And in the second half, you will study about elasticity, creep, and shrinkage. And fifth unit, you will be seeing about the mix design, how to design the concrete and what is the various mixed proportions for different grades of concrete, and finally the durability of concrete. So these are all the five unit content. Now we'll start with the first unit. So Portland cement, how this name came and where is its origin. So in 1824, Joseph Asperdin uh, from England invented this cement and he has the patent rights of it. So what he has done means Portland is nothing but an island near England, okay, where it has some limestone and other clay related materials. So you just burn that one and then you just powder and you once when it is mixed with water, it has some ardent property. So he is the first person to invent cement and he has patented that one. So what are all the raw materials for cement? So there are two main ingredients to make cement. One is calcareous materials. Calcareous means limestone, clay, marl. And next one is argillaceous materials, which is rich in alumina and silica, mostly that clay and shell. So these two materials are combined with some proportions and with some other additives. This cement is made. So regarding the manufacturing of cement, so there are two processes there. One is dry process, another one is wet process. So you will see in detail. See, nowadays in many states we might have seen this cement manufacturing plants. If you see this one, there will be like tall towers and then many small boilers and pipeline running here and there. Once you come across, once you understand this dry and wet process, you can identify which method they have adapted to manufacture cement. And during night time, you can see a lot of lights. Okay, shining during the night time during in that manufacturing plant. So first we will start with the wet process. So the wet process starts with so you know what is meant by wet. Wet means it is nothing but adding water to that. So initially we will take some clay, okay, mix it with water, and then we will make a slurry of it. And next we will take lime, mix it with water, and we'll make a slurry out of that. These two are sent to the wash mill, and then it is stored as a slurry. It both this clay slurry and this lime slurry are mixed together, and it is sent to an rotary kiln where the temperature will reach up to 1400 degrees Celsius. So it is slowly the temperature has been increased. Just a minute. Okay, slowly the temperature is increased gradually. Once it nearer to the 1400 degree in that rotatory kiln, okay, that fusion will happen between the clay and the lime, and then a final product called clinker is formed. The clinker is allowed to cool down, and then it is sent to a ball mill. Ball mill will grind it finely. Before grinding it finer, gypsum is added to prevent the immediate setting. So after grinding it to the fine powder, it is then stored in a silo, and then it is transported to the dealers after packing. So this is about wet process. Next we will see about dry process. In dry process, it is opposite of wet process. We will be mixing this to clay and limestone, but not by adding water. There is a different process is involved in that. Once we grind it to fine powder, we will mix it by a technique called preheater. It will be like a cyclonic rotation. In this slide, you will see in detail. And after that, it will send to a rotary kiln. Rotary kiln means it is a place where the temperature will reach up to 1500 degree to 1400 degree gradually as that mixed raw materials enters, and at that high temperature both this material will mix together and form a final small lump like material called clinkers, and this one is added with gypsum and it is grounded to form the cement, and then it is packed in 50 kg and then it's sent to the delivery locations. So as I told, preheater. So here what is the main difference is that when compared to wet mix is that dry mix, so mixing will be very difficult. So for that, what process they are following is that from the clinker some hot air is extracted and it is allowed to pass vertically towards the top in a circular fashion like a cyclone. You might have seen cyclones happening hurricane like that, many things in foreign countries you might have seen. Okay, it will be like an rounded circulation of wind. So like that we are artificially making it in this preheater chamber. So once under the rotation of this hot air, this two different material will mix uniformly and almost it gets dried up, and the temperature shoots up in this dry heater, and then once it enters into the clean, at less time with less effort the fusion can be occurred. So this is the main beauty of this dry process. Okay, so when compare this to dry and wet process, okay, in wet process the slurry should be heated up so that the water should evaporate first, and after that only that fusion will happen at high temperature. But in dry process, okay, already it is dry only, already it has heated to some temperature in the preheater. So with less time and less effort we will make that fusion easily. So what is the main difference? So dry process means blending is very difficult because it is this and all two different material which is a dry in state. But in wet process, already water is used as an agent to mix it uniformly. And regarding the fuel, less for dry process. Why means it is already preheated, no water is there, so less fuel is required. But in wet process, water is there, you require more fuel, more time to evaporate that water, then only the fusion will happen. And regarding the water mixing, here no water mixing for a dry, but in wet process it is yes. And regarding the cost, so once the water is not there, the time of making that clinker will be very easy, so it is cheap, economical. But wet process is costly. Okay, so in earlier what they manufacturing people will do mean they will go for wet process, and after as time progresses they shifted to semi process. That means both dry and wet process will be there. But nowadays, so as you already know from the comparison, dry process is far more better economical when compared to wet process. So all the cement plants nowadays are running under the mechanism of dry process only, so no water is added, so it is very economical. So I told that clinker, now this is how it will be looking like. Initially it will be too red in color, at the 1400 to 500 degrees Celsius, it will be red hot in color. It is allowed to cool down, gypsum is added, and then only it is grounded. So in that clinker, so there will be some bogey components will be in there. This tricalcium silicate, dicalcium silicate, and tricalcium aluminate, tricalcium aluminoferrate. Like that, these four components, bogey components will be in there. So you can identify easily. So calcium means that lime, silicate means that clay. So both has been fused and it has been combined. So di calcium silicate and tricalcium aluminate, okay, and then tetracalcium aluminoferrate. So it is denoted okay, C3s, C2s, C3a, C4af respectively. Okay, so in the next class we will see about the hydration process.